All right, guys. Okay. So thank you guys so much for sticking it through every single one of these things that we've shown off so far. What Bowen did, what Bowen and Jeff and the team have done with distro is truly revolutionary. It's, I think, a massive moment in the space for people to have an opportunity for redistribution of resources. It's a big step forward for open source. But, you know, we've been talking about training for a while now. So training's great. Training's great. My name, if you don't know, is Karan. I'm a behavioralist and one of the co-founders at Nous Research. And we need to talk about inference. Yeah. Okay. So there's been a lot of stuff going on lately regarding inference, hasn't there? So we know a lot about the more compute I throw during train time, the better the performance of the model. Like more parameters equals better model, right? You can just scale up, make it bigger, get a better model. This is one scaling law we have. And you know, Bowen did a very in-depth scientific explanation of these scaling laws. I'm not necessarily as in-depth about these things, so we'll keep it brief. You also have, of course, you get better data, bigger, more data. You could get a better model this way as well. But recently, people have been talking about the idea of test time or inference time compute scaling. What is that? What is that? You're telling me that you can get better performance by giving more compute to a model during inference time? What does that mean? So I can just throw tokens, like I can just throw and spam tokens faster and faster, or just get more and more tokens, and I can get better performance? Yes, we can. Yes, we can. So I can generate multiple children in parallel, like multiple different continuations or completions of the model at the same time if I have more compute and get better performance? Yes, we can. And so I can actually go ahead and continue the sequence of the best one of those children using something like Monte Carlo tree search or something like best of n or some kind of RL model to rank. Yes, we can. You just spam more tokens and you get better performance. This is what people are talking about. Wow, holy shit. But actually, you have to be optimal about the way that you're doing that. You can't just do it blindly. You actually need to have a little bit of tact in how you're doing that scaling. So let's talk a little bit about the way that people have gone ahead to introduce this kind of technology into the world. There's been a lot more, sorry, I got a little hair there. There's been a lot more conversation around chain of thought reasoning. There's been a lot more conversation about, finally, there's a lot more prompting available for us. There's a brand new technology and technique available for us to have these models, any model, perform better. Well, I can't wait to see it. Well, how does the community feel about the new stuff that's come out? Not your weights, not your model, not your chain of thought. You don't have access. You want to make it better? How are you going to make it better? The people who are going to be coming out with these chains of thought all across the board are going to follow a standard of, we can't show you the chain of thought because it is a competitive advantage for us. So feel about it how you will. Yes, I may boo myself. But that's where Nous Forge comes in. Nous Forge is our brand new project on inference time scaling. And a lot more than that. So let's talk about what that is. Like, what can we do for you? What are we going to do for you? First of all, show me the chain of thought. Okay, I'll show you the chain of thought. Okay, I'll show you the chain of thought. I'll show it to you right now. Just hold on. Let me edit the chain of thought. Let me edit it. Let me go back and change it and change the trajectory and try again. Okay, I'll let you edit the chain of thought. Let me use the chain of thought. Let me take the chain of thought and make a bunch of chain of thoughts and train a model on the chain of thought. Okay, fine. Let me upload my own weights. Let me grab something from Hugging Face, something I made, and throw it in and have that use chain of thought. Okay, later. We're doing a lot. We're doing a lot. The magical intelligence just fell out of the sky. You can wait a couple weeks. So, let's talk a little bit about Forge. I'll show you a little bit about Forge. But since I can't see the screen, I got to just kind of eyeball it a little bit. Okay. So with Forge, we'll just come in, simple chat interface, right? Hi, my name's Shannon. That's Shannon Sands, who's right about right there. Shannon Sands, our chief engineer and architect behind all of this, the truly brilliant mind behind Nous Forge. And so Shannon did a little demo where we say, my name's Shannon, can you scrape Nous Research for me? Pretty simple, okay, we show you this chat log, it's going down, here's the whole fucking text of the whole page, so big it's taken over the whole page, and the generation's occurring. Scrape Nous Research, understood my name is Shannon. Well, I'm not Shannon, but I'm Shannon for now. Talked a little bit about our site, what's on it, what pages there are. Cool, retrieval, that's cool. We've had retrieval for a long time, Karan, why do I care? Well, let's go to the knowledge graph where all the stuff that we just looked at showed up and made associations. So they know we do synthetic data, they know we're doing AI training, they know about Nous Research, they know we do open weights, and right there in this little blob is Shannon. My name is Shannon. So this here knowledge graph is basically us consistently collecting more and more memories for the model, making it more and more personalized towards you, better for you to use with whatever you're using through chats. So let me ask, what's your name? The system prompt just has, your name's Hermes. That's it. That's what the system prompt has got. Your name's Hermes. It doesn't say anything about Nous. It doesn't say anything about us. And the training doesn't say anything about being created by Nous. So here you can see, I was created by Nous. Now, even though we didn't tell it at any point you're created by Nous, it figured this out. How did this happen? Well, if you look to the right, we're showing you this simple chat log. Yes, we'll give you the whole chain of thought. We'll get to showing you the whole chain of thought, absolutely. But I ask you, I'm the main user because when I talk to Hermes, it asks me, are you Shannon? I've spoken to someone named Shannon before. I say, yes, actually I am Shannon. Please note me as the main user. I expected you to call me Shannon right away, but you're doing the emergent thing where you're deciding, well, maybe what if there's another user? I ask, how do you know you're created by Nous? Because I want to see where kind of that's coming from, where that's pulling from. So it looks through its memories, it looks through previous conversation, and it chooses a task. I'm going to give a direct response after retrieval. Hi, Shannon, it's nice to meet you. Glad to confirm you're the main user. I'd love to tell you, it's my knowledge graph and my core programming. Now, the core programming, that's hallucination. You ask another model, how do you know? It's going to say, my core programming, or you just told me. The knowledge graph here, it recognizes it's a new session, and so you didn't tell me. It's in my memory that I was created by Nous Research with a confidence of 1.0. If I come back into the memory section, I can see Shannon is now designated as the main user. I let him know. There's a couple more nodes there. Hermes has expanded a little bit, learning more about how it relates. Let's edit this knowledge graph really quick. Let's come to the graph view. And I want to associate myself directly with the concept of user, which exists inside of here. So instead of Shannon has name Shannon, let's just change it to Shannon is user. We go back to the graph view, and you can see those nodes have connected, no problem. You can make these connections easily, you can remove these connections easily, you can watch and just let it grow to really way too many connections. And we'll note some interesting things about these features once we go past. But now let me just say yo. I've told it, I'm Shannon, Shannon is the main user, I've connected it. I want it to go right away, there you go. Nice to hear from you. I've noticed from our previous conversations that you're Shannon. If you want to chat, we could discuss recent news in San Fran. We talked about it in a previous conversation. This piece is hallucinated. It's not picking up that we didn't talk about San Fran. But if I said in my next message, we never talked about San Fran, please remember we never talked about San Fran. I really don't want it to hallucinate that thing. In fact, never bring up San Fran. It'll come into the knowledge graph, and I will never hear about San Fran again. So this was just a little demo on how Nous Forge works, a little peek into its features. As you can see, we didn't show you about skills or the sandbox, etc. We'll get into that in just a sec. So, some evals. Some evals without the memory system, without this function calling, without any of that stuff, just our chain of thought reasoning. We took Hermes 3.1 70B, and we tested it against AIM, pass at 1. At the No Forge, no reasoning chain version of the model, we got 13.3%. That's like 2 questions right. Once we added it, we got 46.7%. Pretty cool. Now, if we use memory or we used function calling stuff, we think that we could have done better, but that's cheating. But we have that stuff, and if you're using it in your actual prod day-to-day, yeah, there you go. For evals, we want to be standardized and follow the standard that other people have set, and then remind you we have more features that make this better. So From there, I want to talk a little bit more about the more tokens. I can just throw tokens. That's how it works. That's how this inference time scaling thing works. Not exactly. Like I said, you want to do it in a particular way. Sure, what does that mean? It means you're really making reasoning better. If you can set up this good framework for reasoning, you can improve the way that it reasons through stuff based off what the language model beneath it already knows or already may be pretty decent at. It just needs to kind of have that depth pulled out. However, if you need to know what year something happened in and your model doesn't know it, you could throw 50 chains of thought. You're not gonna get it except by just RNGing into that answer. So with historical and scientific facts, we can note that that really depends a lot more on what the model knows. You can still get somewhere. The jump is just not really as big. So we tested on GBQA Diamond as well, and we tried the science questions, those 198 super hard science questions, and the 70B using Forge, as you can see where it scored. We think that the reason that we didn't crash the top is simply because these other models have better understanding, better facts behind certain scientific or historical things. They have better priors. You need to have these good priors for these other things that are like more content-based and less reasoning-focused. But guess what? Guess what you can do if you don't have the right facts? Retrieval and memory, right? If you have the memory system in there, you could just pull out the facts. Oh, we got that question wrong? Okay, we'll learn this fact. Okay, keep it in there. Now do it again. Easy. So the cool thing about these knowledge graphs from a basic level is ChatGPT doesn't remember your name. Claude don't remember your name. Wherever you go in, it don't remember your name. It's not that hard to build in this basic system that can remember your name. We want to give people this kind of feeling of like connection, personalization, like continuous interaction and continuity with the model. So we think that just having some kind of memory system is important. But we don't just think like, oh, you deserve to have it, here you go. In fact, we insist that you have it. We insist to the degree that we give you this knowledge graph that as it builds over time, we'll end up learning about how you want to be spoken to, if you want lowercase or uppercase grammar, if you want certain slang being used, what your likes and dislikes are, to the point that when you switch models, and we've tested this across closed models, when you switch models, it doesn't matter what the RLHF is, it doesn't matter what the training is. These models that tend to fall apart after like 3-4 responses and mode collapse into this instructee behavior are now going to have that behavior overridden by the knowledge graph. That association set actually pushes the model to continue to behave in the way that you prefer. And if you don't like that, of course you can clear the knowledge graph after a certain point, etc. But we consider this to be the default. We consider this to be the default way that people should be interacting with these models. So outside of that, we also have something called multi-model trees. What's multi-model trees? Well, first of all, if you don't know, instruct models suck at search. And anyone who's telling you otherwise is a bold-faced liar. I'm telling you that right now. And here's some examples from a paper that I really like, The Cost of Debiasing Language Models. Creativity Has Left the Chat. They had Llama 2 create, I think it was 70B, I don't remember. But they had Llama 2 between the base model and the instruct model try to generate character cards with Myers-Briggs personality types or people with particular races. And you can see that the instruct model will kind of stick to 3, 5 like groups. The search space is smaller. The base model is literally looking at more options. This is a good thing because if you have an instruct model that has the ability to spawn out, like let's say you have 1,000 GPUs, 1,000 H100s, and you can run 100,000 inferences at the same time, and you can go to depth 10,000. Well, if the model, even at temp 1, is only really exploring like 6 paths, you're kind of wasting a ton of compute because you're not exploring the true search space that you could explore for that problem. So what we learned is, you know, the base model is not so steerable for everybody. That's okay. You can use the base model with the instruct model. You can do something like MCTS or another type of search on top of this mixture of agents, on top of this mixture of models, and do your weighting and value off more than one model. You can use 5 models. You can use 10. If you start making a math expert and a chemistry expert and a physics expert, and sure, you got your MOEs or you've got your small, et cetera, models, whether you believe in one big giant model rule them all or a swarm of experts, put them together. Put them together and do search on them because that will stack and scale with this new inference time scaling law that people keep talking about. The thing is, people who made this one foundation model and are selling everything on it are going to serve that model and their cousins. People who are making from another architecture are going to serve on that and their cousins. We don't care. We will use any models available to improve performance. We'll just continue. Oh, sorry, I lost that. We don't care. We'll take OpenAI, we'll take Anthropic, we'll take Hermes, we'll take whatever Mamba thing comes out. We'll take whatever. This is a model-agnostic infrastructure that will only get stronger as you add more models. Now, to what end? Like, where does that scaling end? I don't know. We haven't taken 50 models together and put them together yet. But this is the opportunity and time in which we want to invite everybody to try this kind of system, to help us improve this kind of system, to use and make data from this kind of system. Hold on. And finally, something that you may have seen just a second of inside of our demo are the reflexes or skills. If you need something done, like search on the internet for me for this thing, the model is utilizing a code interpreter as well. So the model will be able to, write and build out function calls for the kind of tools or things you need. If it's not doing it right, and you know how to write it better, paste the function call into the chat and tell it save this as a reflex. Just talk to it. It's fine. And it'll learn, it'll save it into its library, and the next time that you try to do this skill, it won't cost you the tokens, and it won't cost you the time. And as this builds up and you have more and more things you're doing regularly, you save more and more time as you utilize this library of reflexes. If you have a complex task that took 5 or 6 of the different tasks, subtasks that you created, that's happening super fast now. You're not waiting so long for it to happen anymore. So between the reflexes, the memories, and doing our MCTS search with chain of thought reasoning, all these pieces that we're going to absolutely show visibly, have everyone be able to utilize, have everyone to be able to interact with, we're inviting you to join now, sign up now, because we'll be taking people in on a rolling basis over the next few weeks. We'll be opening up the beta in a few weeks, and then we'll be accepting people on a rolling basis. We've never, ever had any kind of release where we had to host people, let alone 100 or 1,000 or 10,000 people before on our servers and build the infra for all this. So we want to grow with you. As we host our first 100 people, we want it to be you. As we host our first 1,000, we want it to be you. And as we scale this up for everyone to be able to use, which we'd love to give it to everyone now, but we literally can't afford to host for all these people. As it stands, we just want to invite you to come join, give us feedback, show us what you like, tell us, hey, I actually want more of this, I'm not getting the data I want, etc. Get back to us, share in the Discord, sign up for the wait list, and we'll make this the best possible inference engine for all of you. Alongside that, it's not just going to be, can I only access it on the web app? No, we absolutely are working on API endpoints as well, drop-in replacement for the OpenAI API style schema. So you'll absolutely be able to use this to superpower any of your existing applications, workflows, et cetera, as well. That's it. Thanks for coming. Thank you.